Hey, Jeremy Nagel here, talking to you today about Lambda versus Glue, my experience with using serverless ETL and machine learning. What I'm going to cover today is a couple of case studies about using Lambda for ETL and machine learning, and an explanation of why my colleague and I went down that route at GOFAR. Before I get into it, I should say that I'm not an expert at PySpark, and so any aspersions I cast towards Glue are probably based on my own lack of skill there and my level of comfort with Lambda instead. So if you do great things with PySpark already, please keep doing them. This is more for people like me who I'm not really a proper data engineer. I'm just cobbling things together, and I've mostly got them working, sharing them in the interests of other people who might be interested in playing around with Lambda and seeing what is possible to do with it. To give you some context on what I was trying to achieve, I work for a company called GOFAR that does mileage tracking for drivers. That might be an Uber driver or someone who's a courier. They're driving around all day, and because they're using their own vehicle for business purposes, they're allowed to claim that back in their tax return. They need to have some data on what trips were business related and which ones were for personal use. And I'm mentioning that because that's one of the use cases later on, that part of what I was trying to achieve was using machine learning to automatically categorize trips as either being business related or non-business related. But let's begin with the very first high-level overview of one of the ETL jobs that we had. For a long time, GOFAR was coping with data ingestion in a relatively naive way, where we were ingesting data in real time using a Node.js API and directly dumping that into our database. That worked well for a couple of years, but we reached a scale, not super big data scale. We've only got 2 terabytes of data in the database, but even at that point we were starting to see issues where by doing all of these ingests at the same time, we were really causing our database server to struggle a bit, and it was also compromising the performance of the backend API. For that reason, we wanted to move to a model where we would put the telematics data, as we collect data every 2 seconds from people's phones while they're driving around, and that data, instead of immediately ingesting it, instead we put it onto a queue, which means that in peak hour, when there's a lot of telematics data being uploaded, we're not trying to do it all at once. Instead, we can gradually fill it in as our servers have capacity later in the day. And what we wanted to do, as well as putting it into the database, was have a transformation layer where we could do some aggregate statistics. We could look at, were people driving safely during that trip? We've got data from a accelerometer that's plugged into the car's diagnostics port, which means we're able to know where they're really putting the brakes on hard. And based on that, we can identify trouble spots, and we can also help the drivers to understand whether they're getting better at driving in a smooth manner over time. We wanted to be able to calculate those trip level statistics based on the raw data, which meant that we needed a transformation layer. We weren't really sure how to handle that. We could have just done it in the normal Node.js backend API, but I mentioned that we were already starting to see problems with that. We didn't want our request times to become even longer. Instead, we wanted to have a separate ETL layer, and probably not use Node.js, probably use Python instead, because it seems a bit better suited to these not super duper data sciencey, but moderate level data analysis tasks, which meant that we had to think about how we would run that Python code. Would we use Spark? That's one option. Would we have an EC2 instance, or a fleet of autoscaling EC2 instances? Would we use ECS and run Docker or use Kubernetes? Or would we have a crack at using Lambda? And in the end, I personally find Lambda really nice to work with as a developer. It means I don't have to think about infrastructure as much, and so I tend to default to Lambda, and only when I discover that something's impossible in Lambda will I resort to the heavier duty ways of being able to run code. In this situation, for what GOFAR is doing, we've been able to do all of the ETL steps via Lambda and also some machine learning. So I'll start out with a bit more detail here about pros and cons of the different approaches that Glue is designed via PySpark for ETL and a little bit for machine learning as well. It's meant for operating at scale. The con is that I've only used it a little bit, but I found it impossible to understand. I got it. It's a combination of me not knowing PySpark very well, and also that AWS has admitted to me that the errors that you get out of Glue when you're running it are pretty incomprehensible, hard to use, whereas if you're running Lambda or a ECS task, it's pretty easy because you can get standard application exceptions out of that. With Lambda, the biggest pro is that it's super easy to develop and deploy. The con is that if you're wanting to do an analysis task that takes more than 15 minutes, then you're out of luck there. And then with ECS, you don't have to worry about timeouts, but the con is that it's not really a cool technology choice. It's a bit boring. So I wanted to stretch the limits a little bit. Start out with one of the easier things to do, which is the ETL step, where we're wanting to transform the telematics data and do some aggregate level analysis of it. For that, I'm using AWS Cloud Development Kit, CDK, to define the infrastructure. You can see here that setting up a Lambda function, passing in a secret, which has all the database passwords and other secrets we might need, as well as a queue, SQS queue URL that it will pull data from, and also we're pushing data to a third-party service, Compass IoT. That's another SQS queue there, and then granting permissions down the bottom. Here's the Lambda handler. You can see at the top I'm trying to do something around having an RDS connection pool. We're using Postgres 12, which means that at the time of recording, RDS proxies aren't available, but I'm really eager for that when it comes. And then the code is pretty simple, and I'd argue for me pretty easy to understand, that we grab some data out of SQS because this function is triggered by SQS events. Basically, the backend API will push a SQS message when it receives a batch of telematics data, and then this Lambda function will process 10 of those messages at once. Then we pull our database username and password out of AWS Secrets Manager, generate a database client, and then we push the data to our Postgres database, and we also upload it into S3 in parquet format. There's a bit of detail to both of those steps, but relatively elementary code around using Circo PG2 to push the data to the database, and using a parquet formatter in TypeScript to upload the data to S3. The next challenge that we had was we were pushing data in parquet format to S3, but the problem was that our files were very small. The documentation for Athena recommends that you make your parquet files around about 128 meg. Initially, I was pushing them at around 4 KB. I then batched it up so that there were 10 of them at once, and then it was more like 18 KB, which is still way too small. For that reason, we wanted a way that would merge these parquet files together. I couldn't really find a nice, easy way to do that. There's meant to be a way of achieving it via glue. I couldn't get that to work. And then there were a bunch of blog posts that didn't really do it in the right way, because in order to really actually improve the query time, you can't do the naive way, which is to basically concatenate the parquet files on top of each other. The reason why that doesn't work is then you have header files, or the header row, repeating every, I don't know, 100 records or so, which means that for Athena it doesn't really speed it up. So instead, what I did is set up a Lambda function that used PyArrow to, well, first it loads the parquet data into a pandas data frame, and then it concatenates all of the pandas data frames together, and then finally it uses PyArrow to generate a merged parquet file. You can see here that after the first pass, it converts those 15 KB files into about 2.7 meg, which is an improvement, but not quite good enough. The third step is that it then merges those 2.7 meg files into a bigger file. You can see here that for this hourly partition, there was 17.8 megs worth of parquet. And that's all of the data for that hourly partition. It's not quite 128 meg, but that's all of the data. And Athena is smart enough that the way that we've set it up, we've got a key with hour equals 12 or hour equals 13. It will only scan within that path, which means that it's only going to be looking at one parquet file. 17.8 meg is therefore pretty good. So the code for that, I don't seem to have it there, but it's basically as I described it. It uses the AWS S3 SDK to download files from S3 based on a path prefix, and that prefix is based on the partitions where we would have the hour and a date string, basically an ISO 8601 date string, and then we look at all of the files that are in that particular partition. We're able to then download. The reason why I did it in 3 stages is because I was concerned about the Lambda function timing out. So instead, we process about 5,000 of these files, and that takes around about 10 minutes. And then after it's done with that, it pushes the file into a processed subdirectory, even though it's not really a directory in S3, that essentially the file key contains processed. And then finally, stage 3 is that if there are no files in the raw data subdirectory, it will then look in the process subdirectory, and it will do the same thing of reading all of the files into a pandas data frame and then spitting them out again into a merged file in here. The thing that was slightly complicated about this is that PyArrow is quite large. I think behind the scenes, maybe it uses a Java binary, which means that the size of the code in total is more than 250 meg. That limits what you can do with Lambda. With Lambda, there's a problem where you have 500 meg worth of storage in your temp directory, but your Lambda function zip file cannot be more than 250 meg. I've tried various options around using Lambda layers. Same issue there. Even if you try and put the PyArrow dependencies into a Lambda layer, the total size of all of your Lambda layers and your function code cannot exceed 250 meg. For that reason, we have to use what's called a slim handler. This is borrowed from the Zapper framework, which is a kind of like the serverless framework, a way of pulling in, or a way of building your Lambda functions and deploying them. What it does is it creates a slim handler, the opposite of this little dog here, where the slim handler just has one job, which is to download the main the main Lambda binary from S3. It downloads that from S3, puts it in the temp directory, changes to that directory, and then with XAMPP you've got your Lambda code and also PyArrow and any other dependencies that you want there. That allows you to get around the 500 meg limit. The other way to achieve this is to use EFS. When I was writing this code, EFS support for Lambda didn't exist, and you can now do it that way. I still am happy with my S3 solution because it generally works. If you were running a more inconsistent or irregular job where it only ran once an hour and you were very conscious of cold starts, then you probably would want to prefer an EFS option. But for me, because these functions are running hot, they're running basically at the concurrency limit. I think I've got it set to a concurrency limit of about 5, which means that at any given point, there's always 5 running, basically. Okay, here's the CDK code for it. The fat lambda is stored in a S3 asset. That gets turned into an archive, a tar file, and then that S3 asset, the key for that, is passed in here as an environment variable, which means that the Slim handler knows where to find it. The other thing, even though I didn't use EFS to store my dependencies, I did use it as a bit of a hacky state management system, because I needed to be careful with concurrency that I didn't want multiple Lambda functions trying to download the same S3 files. For that reason, I set up an EFS system where definitely the wrong way to do it, but I couldn't be bothered spinning up DynamoDB. So I'm just touching files in order to indicate which S3 directories are currently being processed. And then after it has finished being processed, it deletes that. Well, it's not a file, it's a directory. That worked pretty well, but I did experience a bit of a bill shock because I'd copied the EFS code off the AWS blog, and they had set it up by default with the code had provisioned concurrency or provisioned throughput for EFS. You can see up here at 1 gigabit per second, which is quite pricey. I think I ended up spending about $800 on EFS throughput in the space of 3 days before I realized. And the S3 API requests were also quite massive too, because I wasn't quite doing that in an optimal way. So you want to be careful with these things. Keep an eye out on the billing. I had an issue with our billing alerts where they weren't coming through, and I missed it for a couple of days. But thankfully, AWS were nice and acknowledged that their code sample didn't have it spelled out that if you set 1 gigabit per second of provisioned throughput that you're going to pay through the nose for it. They refunded the throughput costs. But be careful with that. My final case study is going to be about doing machine learning on Lambda. The difficulty with this is, again, with the binaries. In my case, what we were trying to do is we were trying to predict whether a trip was business related or non-business related. You can see here a very grainy decision tree that was generated by XGBoost, which is the machine learning model that we were using, where you feed it a whole bunch of features and then it's able to spit out whether a given trip is likely to be a business related trip or not. XGBoost weighs about 250 meg, which makes it pretty hard, but I use the same fat Lambda trick to get it to work. Here's the code within the Lambda, where we're passing in a whole bunch of features. We're using Smote to do some rebalancing of the data set, because you get issues in our case where 80% of the trips weren't business related and 20% were. Generally, XGBoost and most machine learning classifiers won't work too well with that. You need to get it to more of a 50-50 ratio. And that's what Smote is good for. You can see here we're then passing the data into XGBoost classifier, generating then a model. and then checking the accuracy on that. What we do then is that if the model on the holdout data on the test data set, if that achieves more than 95% accuracy, then we treat that model as being a good model and we store it in S3. We then have a inference Lambda that downloads the models, and the models are per user. After a user completes a trip, it will download the models from S3. It will feed in the features for that particular trip, and then it'll get a probability of whether that trip needs to be tagged with the tag that relates to a certain model. Here's the CDK code for that. Again, we've got here the rebuild model dependencies, sklearn, XGBoost. They're pretty big. I think in total, we're running pretty close to the temp file limit. I think we're maybe at 460 meg in the temp directory, but we're able to fit it all in and able to train models like that. And then here's the inference Lambda, where we pass in, again, the same dependencies. It has to use XGBoost. We're not using TreeLite or any of the smaller, lighter versions of the model where you wouldn't need to have sklearn and all of that. We are using the same dependencies, same technique with the fat Lambda, and then an SQS trigger for that Lambda. I'm going to finish up by talking about where Lambda doesn't work for me. I'm still using ECS or Docker for web servers. I know that some people are playing around with using API Gateway and using Lambda for that, but I personally still like my monolith for the backend API. And I've also got a few analytics jobs which I initially tried to get working in Lambda, but they ended up being too slow. They timed out after 15 minutes. So I find ECS is a good solution for where Lambda doesn't fit. And then thinking about what it would take for Lambda to be the default choice for almost everything for ETL and ML, I'd say the file size limit is probably less of a concern now that we have EFS support. However, execution time is still a concern. It would be really cool if you could have more than 15 minutes. I mean, it was a game changer when it went from 5 minutes to 15 minutes a few years ago. I'd really love to see it increased even further, because there are some things where you can't really use step functions and interrupt it halfway. For example, with some of the database queries that I'm running on our read replica, they're pretty slow. One of the queries might take 15 minutes on its own, and you can't really interrupt it halfway through. Then the other thing that would be handy is RDS proxy. Looks pretty cool, but doesn't work for Postgres 12 quite now, but hopefully that'll be supported in the future. And the other thing that would be pretty handy is a way of, and there probably are already ways, I just don't know how to do them. So if you have ideas, let me know, around using something like Apache Airflow to orchestrate the data workflows. Right now I'm just stringing together SQS queues and it feels a bit hacky. Just like Lambda functions, my speech is about to time out. I'd like to leave you with a job opportunity. GOFAR is hiring a backend developer to continue this kind of work. If you have better ideas on how to manage these sort of ETL and ML workflows, love to hear from you. You can shoot me an email at jeremy@gofar.co. That's all I have. If you have any questions or contrary ideas, please shout them out now as I hand back to our esteemed MCs.